Hello everyone and welcome back. My name is Mr. Covalt, and in this video I'm going to be going over how to calculate the new mass or the amount of mass that has been added or subtracted from an iron bar that's been sitting in moisture, and some of it which has been converted into rust. So let's get into this. Here's the problem. You have an iron bar, weighs 664 grams, or at least it used to weigh 664 grams, but it's been standing in moist air for a month now, and exactly 1/8 of the iron in the bar has turned into rust, which is Fe2O3, or iron 3 oxide. Calculate the change in mass. Assume any rust that's formed remains on the iron bar. Okay, so the key here is that we're looking for the change in mass, not what the new mass of the bar is, but the change in mass of when the bar was 664 grams before it changed into rust, and after it gained rust. So what are we going to do? So first, we need to figure out, well, how much of the iron was converted into rust. And they tell us that on standing in moist air for a month, exactly 1/8 of the iron has converted or been changed into rust. So what is 1/8? We need to know what 1/8, because we got to use that to convert into rust. So that's the first thing. So we're going to take 664. So 664 grams, and we're going to divide that by 8 to get 1/8 of the bar. And when we do that, we get 83 grams. So 83 grams of the iron was converted into Fe2O3. So now that we know how much, or what's the mass of the iron, oops, that should be Fe, not F. Now that we know that the number of grams of iron that was actually converted to rust, then what we can do is we can see, okay, well, what mass of rust was formed from the iron? So we're going to need a balanced equation, because this is stoichiometry. So we're going from one substance to a different substance through a chemical reaction. So we need to write down our balanced equation. So we're going to have iron solid reacting with O2 gas, and then that's going to give us Fe2O3. And when we balance this, we should get 4 iron atoms, 3 oxygen, and 2 Fe2O3. So here's our balanced equation that we're going to use to convert 83 grams of iron to whatever grams of rust that were formed from the 83 grams of iron. So let's go ahead and set that up. So we're going to start with 83 grams of iron. So we have 83 grams of iron. And we're going to use stoichiometry. We're going to use our conversion factors to convert grams of iron to grams of rust. And this is a mass to mass conversion. So we got to use the molar mass of iron. So we looked that up on our periodic table, and that's 55,845. So 55,845. Let me double check that. Yes, grams of iron. And on the top, we'll have 1 mole of iron. So grams of iron cancel out. Now we have moles of iron. Now we can use the mole ratio in our balanced equation to convert moles of iron to moles of rust. So we have a 4:2 ratio. So we'll go ahead and use that. So since I have moles of iron on the top, I'm going to use 4 moles of iron on the bottom, 4 moles of iron. And on top, I'm going to use 2 moles of the rust. So 2 moles of Fe2O3. So moles of iron now cancels out. And now I have one more step. I have to use the molar mass of rust to convert moles to grams. So what's the molar mass of rust? That's going to be 159,687. So I'm going to put 159.6, what did I say, 87? Yeah, 687 grams of the rust, Fe2O3. And on the bottom, I'm going to have 1 mole of the Fe2O3, the rust. So moles of Fe2O3 cancel out. Now I have grams of Fe2O3. Now all I need to do is multiply by everything on the top, divide by everything on the bottom. And when I do that, I get 118,66118.66. Got a couple more digits. 79 grams. And this is grams of the rust. So Fe2O3. And let's check our sig figs. So here we have 2 sig figs. And this is exact. We got more sig figs, So this is going to be 2. So we should only have 2 sig figs. So we'll put a line under there. We'll keep the rest because we got to do more calculations and we don't want to have a rounding error. Really, you just need to carry just 1 more extra digit, but I'll carry the rest. It's okay. So now I have the mass of the rust that was formed from 83 grams. So now what I can do is I can figure out what the change in the mass was. And so here I know 83 grams of the iron was formed into, let's make this more visual. So I started off with 83 grams of iron, and I got from that 118 we'll just do 0.67 grams of the rust, Fe2O3. Well, this 83 grams was part of the 664, so I had 83 grams, but now I end up with more. So what's the difference between these two? Find the difference between these two. You find the amount of mass, the change in the mass of the original iron bar. So all I have to do is take 118.67, subtract 83 grams from that, and I get, what do I get? I get 3567. So 3567 grams. Since I'm subtracting, remember the rule is when you subtract or add, the answer you get should have the same number of decimal places as the least number of decimal places in the measurements you are adding and subtracting. So here I have 0 decimal places. Here I have 2. 0 is the less. So I got to cut it off at the after the 5. So I have a 6 here. So I got to round this up to 36 grams. So that is our answer. Our change in mass, the difference in the mass is 36 grams. Our iron bar has gained 36 grams during the month that it was exposed to moist air. That is how you do this problem. I hope you enjoyed this video. If this was helpful, if this helped you with this problem, or you learned a lot from this video, then please, by all means, like the video, share the video, hit that like button somewhere over here, I think. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. finally put a comment down below in the comment section. I would love to hear from you. If you've got a question or a problem you need help with, put that down below. If you have a topic you want me to cover, put that down below. I would love to do that for you. Thanks for joining me and have a great day.